have the Newton's laws of motion, and its application is obviously law 1. Everybody continues in its state of rest or uniform motion in a straight line unless acted upon by an external force, or unless an external force acts on it. Then this law is called the law of inertia, and we're saying that inertia is the reluctance or tendency of a body to start moving if it was at rest, or stop moving if it was in motion. So it is sometimes called the law of what? Inertia. Now this one explains the following. Number 1, the passenger jacks forward. Why? A passenger standing in a car, when the car starts moving, jacks backward, and when the car stops moving, jacks forward. Why? We shall say, here we can put a note and say, passenger standing in a bus jacks backwards when the bus suddenly starts moving. This is because his legs being in contact with the bus share the motion of the bus, but upper part of the body is still at rest. So the person jacks backward because of inertia. Next bullet, you can say, a bullet fired in the window glass makes a clear hole without causing cracks. The rest of the glass is unable to share the motion and remains at rest. So that is, they can ask you to explain that. Yeah. So then the other one is law 2. The rate of change of momentum of a body is directly proportional to the applied force and the express direction of force. So this is the change in momentum. The rate is divided by what? Time. So force is equal to constant times the rate of change of momentum. But V minus U over time is given as acceleration. So F equals constant times ma. But if the force is 1 Newton acting on a body of mass 1 kilogram to cause an acceleration of 1 meters per second squared, then when you substitute, our constant becomes 1. So since our constant is 1, we shall now say our force is equal to ma. Then we can say that SI unit of force is Newton. SI unit of force is what? SI unit of force is Newton. Small n, Newton. Then O, and this capital N as a symbol. Then we can define a Newton by saying a Newton is a force that gives a body of mass 1 kilogram an acceleration of 1 meters per second squared. So we move on. Law 3 says to every action there is always equal but opposite reaction. There is equal but always. Examples of third law of motion. A gun moves backward on firing. Number 2, a ball bounces on hitting the ground. A ball bounces on hitting the ground. Then we go to the motion in a lift. That is application of which law? Motion in what? In the lift. So motion in the lift. The lift moving upwards. So let's say this is a lift. So here we have, now this body has the weight downward. The body in the lift has the normal reaction, and here it has the weight of the body downward, and the lift is moving up with acceleration A. So I shall say that the resultant force will become, since it is moving up, this is R minus the W. but W is same as M at mg, and F is same as MA. So our MA will become R minus mg. So our reaction will become MA plus M at mg. So our reaction will become M into A plus G. That is case number what? Number 1. So we can go to case 2. Case 2. Moving downward. Moving what? Downwards. So we have the lift. So here we have normal reaction. We have the weight. It is moving downward with acceleration, which is it. So the resultant force. Resultant force will become what? W is greater than minus what? R. That means that MA is equal to mg minus R. So here, so our R will become mg minus MA. So our normal reaction will now become M into G minus what? Minus A. That's why when the person is moving downward, he feels weightlessness. Okay? He feels as if he has lost weight because of the apparent loss. The normal reaction here is reduces. Okay? It's as if you are not, your legs are not on what? On the floor of the lift. Okay? As if you are being left in the space. But when you are moving up, you really feel that the lift is lifting your weight. Okay? Your weight is being carried upwards against the gravitational force. Then we have another one. We have another one. If case 3, lift moving at a constant, velocity. So i.e., if the lift is moving at a constant velocity, it implies that it is not accelerating, therefore acceleration is what? 0. Whether moving up or downward, you have the same effect. So let's check here. We have already R is equal to here. On this one here is equal to mg minus what? MA. So that implies that our R will become M what? mg. If it's moving at constant velocity, acceleration is 0 because it is not accelerating. Okay?